We did invite the Board of Selectmen and the town manager, and
Yes.
you individually contacted any one of them.
Yes, and he had a conflict. He was going to try and rearrange. He may be stuck in the same traffic jam that I was stuck in. But anyway,
Sure.
I did reach out to the town of Bourne.
Okay, and we did as well. So, anyway, go.
You were saying McGanson's in Falmouth. You want to finish that thought? Squetig is in Bourne.
Squetig is in Bourne, which is why we invited Bourne.
Hey, Jerry.
Okay.
All right.
So this is the last of our 15 estuaries, I guess.
Yes.
Oh, I'll get to that. I mean, I am so happy. I mean, Falmouth has more estuaries than any other town in southeastern Massachusetts by multiples. All right, it's fine. I mean, Bourne has a bunch, but no town has 15 estuaries. It's just a lot. So that means you have a lot on your plate because most of them have some level of impairment somewhere. And so there has to be then a lot of work done. But then again, what it means when you have that many estuaries, you have all that coastline that nobody else has, right, as well. So I'm really happy. The town really bit into this, and it's been years and years and years, but to get 14 estuaries done, completed, and passed along is really something that the town needs to be commended for. I mean, it's just, you're like 4 towns worth of stuff, okay? It's really impressive to me sitting on this side of the table. Well, today I'm going to talk about McGanson and Squetig's loading analysis and management thresholds. The Massachusetts Estuaries Project has been working in Falmouth, as I said, probably since, on the MEP, probably since about 2003 or so. And since way before that, in terms of just even getting how you would monitor estuaries and all of that work, a lot of that was pioneered in Falmouth as well, which again makes sense since 14 estuaries, right? Falmouth had the first nutrient overlay bylaw, which led to a lot of this stuff. So I'm taking you back just a little bit because people forget just that towns have really been working very hard on these things for many decades, and it is only recently, not that 2003 is recent, but it is in this game, which goes back into the 70s, that the towns really did kick this off in this region to get these things done. It has not been top-down, it's been bottom-up type push. And the agencies have come along very well, recognizing that the towns were interested and have come along and have been very proactive after that point. All right, the Massachusetts Estuaries Project, you've seen this before. Matter of fact, you've seen it 13 times before, 13 previous talks. But I want to just say it a little bit differently now. Where it is a partnership between the regulatory agencies, the municipalities, and all of the municipalities listed and the agencies listed do contribute to the project as opposed to just being listed. They really have put in data, time, money, and other things that have really helped. DMF, for example, has given us use of their facilities and also has given us data to help on shellfish distribution and such, just as an example. But the reason for showing this today too is that I've always showed this and say, well, Mass DEP under EOEA, which is now EOEEA, does the regulatory and TMDL part, and that's what's coming next for this system and actually your other systems that are in the pipe. You'll be getting the regulatory piece, which codifies the estuaries project piece, okay? We do the science, they do the regulatory part. And where we're at right now is that we have developed, this is a purpose to develop nitrogen thresholds where we've done that now for each one of the estuaries, including what you'll hear today. And really it's the target nitrogen loads from the watershed to the estuarine bodies that allow management plan. That's really what we're after more than anything else. If the system is impaired, then there has to be a plan to make it unimpaired, and if it's not impaired, then what we do is we actually look to see how much more nitrogen you would put in so you can plan for the future and build out and such, okay? Okay. The purpose of the estuaries project focuses on nutrient loading, primarily nitrogen to estuaries, and the problem with it, and the reason it's a primary threat, is that an excess of nitrogen going into these estuaries doesn't just affect it a little bit, or you can't eat the shellfish, or there's there's some problem with habitat. What the real problem is that there's a wholesale decline in the estuarine health. So you lose your food sources for migrating birds. You lose, well, a good example is that. You lose eelgrass, you lose all the species that depend on it. There's sea ducks and geese that rely on eelgrass for part of their life cycle feeding. There's blue crabs, and there's scallops and other things that rely on it as part of their life cycle. There's also habitat protection, shoreline protection, because it breaks down waves. There's a variety of things that happen if you lose eelgrass, and yet eelgrass is the most sensitive habitat within these estuaries to nutrient loading. It's the first thing you lose. And so there's a lot to be lost if we overload the systems. It's not just a question of that, it doesn't look good or something like that. We're actually affecting many levels, including the economy, including offshore fisheries that use these systems for nursery grounds. As they migrate up and down the coast, they go in to feed, but if the habitat's been destroyed and there's nothing for them to feed on, then there's going to be less migratory fish going up and down the coast, just commercial and recreational. This is the MEP region. I think I put this up more for me than for you. I just like seeing all the red dots, which are the ones who have finished. And there's a couple yellow ones which are underway right now, and I mean really underway. And there's a few, recalcitrant ones out there, some that are planned and some that have moved off, like Promised Harbor fell off the list because our initial surveys of it said that it wasn't impaired, and it was so far unimpaired that because they sewered the watershed as well as the harbor's well flush, that we decided that it was not worth it. We should put our money in other places where there are impaired water bodies, like Falmouth.
One quick thing.
Yep.
You will add Herringbrook. It's an impaired waterway. It will need an MEP report. I don't know how we're going to fund it, how the state's going to fund it, but it's...
I know, there's a couple of those.
Just for, it's... I don't know what the resolution is, but it's now an official impaired watershed.
You are right. And we have this problem on the vineyard where actually we have funding from the communities out there. They want it done, but the project is running down on its resources from the state. So the question is, will it push out to get those done or not? That's being discussed now. I mean, I think that in discussions with the Boston office at DEP, they want them done. It's not that they don't want them done. It's a question of, under this economic conditions, how are we going to get it done? Mm-hmm. Okay. You can see there's 3 in Edgartown that want to be done. Okay. My favorite slide of the talk. These are the systems that have been completed, with the underlying ones being what we're going to talk about today, for Falmouth, that either are whole or in part or affected by Falmouth, like Squeatika is affected by what goes on in Falmouth, even though most of the harbor is in Bourne. And most of these, or at least a significant percentage of them, have TMDLs already. Some will get them coming down the road. I would say that looking at that list, that all of them are impaired. Okay, all of them have some form of impairment. Quisit's really the closest to not being impaired, but it has a little bit of impairment, which I think the town is looking at some innovative ways to deal with that impairment. Not all solutions have to be one size fits all. Okay. All right. For those out in TD land, the reality is that the sequence of adding nitrogen to estuaries, it's a cascade of effects. At first, like in Quissit, it's clear water, it's pretty healthy, but you start adding nitrogen in and it gets some phytoplankton blooms, not really big ones, but then over time with more and more additions, as we titrate in more nitrogen, we get turbid waters, and then, as is happening a little bit in Quissit and is happening in many of these other systems and is happening a little bit in Megantic, you start to lose your eelgrass beds. If you start losing eelgrass beds, you lose all those services that depend on them, and all of those other populations that are economically important that also rely on them. So you start diminishing a bigger and bigger area of, or suite of things which affect not only the tourism industry, people's feelings about the estuary, but also straight economics. Over more nitrogen going in, we start losing our benthic animal populations, which are the base of the food chain for a lot of fish. and also for avian populations. So actually, nutrient additions can actually cause declines in the bird populations. And then at more, you get low oxygen. Some systems have no oxygen periodically now in the summer. It used to be that every summer we sort of predicted the week that we would see fish kills in different estuaries in Falmouth. At higher levels, we get these macroalgal accumulations where there's floating mats on the surface. They don't live on the surface, they live on the bottom, but as they start really producing a lot of oxygen, they lift off and they float on the surface. And that's when people a lot of times get upset, but of course the system had been significantly impaired way before that when they were on the bottom and you didn't even see them. Classic example of that was Wacoit a number of years ago, but maybe 7 years ago, where there was such a large macroalgal float to the surface that people couldn't get from the shore out to their boats, to their mooring, because there was just so much algae floating on the surface. But of course that had been documented 20 years before, and that the bay was in big trouble, is heavily impaired because of this, but it was only when it came to the surface and people could see it that there was a big hue and cry to do something. Of course, something was already being done at that point. All right. And this isn't a Falmouth problem or a Bourne problem. This is really a worldwide problem. We've already lost more than 65% of all our seagrasses worldwide. And we've lost more than 50% of our historic keelgrass in southeastern Massachusetts. And this is, historic means back to the 50s or so. It doesn't mean all the way back before there was the wasting disease. This is the post-recovery from that natural process when it all had expanded out, and then now this is the human effect. The human effect is to get rid of that habitat. We also found through the MEP, because we've done pushing 70 of these estuaries with spatial detail, that we've found that we're lost about 50% of our benthic. We haven't lost it, but it's impaired or degraded. In some cases, like in Papaneset Bay, Aquay Bay, every summer, all of the animal habitat is non-existent. All of the animals die, and what you're looking at is just black mud, and that happens in a variety of, I can name a number of basins and estuaries in southeastern Mass where that's the case now. Didn't used to be the case. That resource is then lost to people. All right, so what do we need to do? There's no magic bullet. There's only two conceptual ways that you can restore the estuaries if there's too much nitrogen. The first way is pretty obvious. You manage the nitrogen that goes in, which means you lower the nitrogen going in. If there's too much there, you put less in. The other way, which we've experimented a lot with the MEP, we know it works. It's being done a variety of places. It's done frequently every year in certain places, which is to increase the tidal flushing. So you can either control the inputs or you can increase the outputs, the rate of output. And that balance those two items have the same effect. And a lot of systems now in southeastern Massachusetts have had some tidal flushing enhancement. Now they've increased it with good effect. Others need it. You guys have a project potentially to increase tidal flushing, tidal exchange in Bourne's Pond in Falmouth. I think that, from all of our work at the MEP, we would say that actually is a very good project. It should work for you. Yeah?
When you said every year, you just said about flushing. You said there's something about. Did
some
you mean
systems.
There are new projects every year, or that there's some sort of annual flushing regime?
Both. What they do is that some towns used to maintain their inlet flushing, dredge the inlet every year, or no, and not every 5 years or 10 years. The problem with that is that if you wait 10 years and it really occludes, the health of the water body goes way down during that process because it's not flushing. And so it starts to decline, the water quality declines, habitat. Then you open it up and it goes up, it improves, and then it declines like this. The problem is that you've damaged a lot of estuarine habitat by waiting. If you dredge on a every year, every 2 years, every 3 years, whatever your inlet needs to just maintain it doesn't occlude much. Then what happens is you don't get that boom bust thing. But the other thing is you don't have to go and dredge into the estuary that much. Your footprint is quite small. The amount you remove each year is quite small. And now we've worked with, as Falmouth did and other towns did, with Mass DMF and DP to get some leeway for that type of dredging make it more possible for the towns with the time of year restrictions, so that you can go into your inlet and off a little bit without a huge restriction in your time. And that's because they know, a lot of people don't like dredging at all, but if you have to do it and you're going to do it, it would be better if you did little amounts every year in the same little place, rather than waiting and then having to do big amounts with a big footprint and a big disturbance to the system. So, and you get the same effect, yeah.
Roughly ballpark, how many estuaries have pursued this flushing strategy since the MEP?
More than you can imagine. I mean, okay.
A dozen, 2 dozen?
More than a dozen.
More than a dozen.
But they're different. Like Mashpee got a revolving fund for dredging, so they dredge every year, and they use it for beach nourishment, because if you're just doing it in the inlet, you can do that. So they don't have disposal problems. Whereas if they didn't, then they had real problems. They had disposal problems, and they had to do big areas. So now they're in this routine. That maintains the flushing at maximum in Papaneset Bay. The vineyard, there's 4 or 5...
Sessachacha or something.
Yeah, and on Nantucket, there's Sakacha.
Oh, okay.
Well,
Okay, so are
those
they...
are totally open. Those close completely and are opened. And now what we've done is modeled them so that they would be opened at a better time for water quality, rather than just opening.
Would you have a list?
Oh, yeah.
Okay,
I mean, we could put together a list.
great. Yeah, I think it would be useful to know, because we're looking at that at Bourne's Pond, specifically, how many other locations have already been approved by DEP for that strategy?
Well, I'm trying to see in my mind, there's 2 that immediately come to mind, 3 that
Okay.
I better stop. There's a lot of effort pushed to widen the railroad bridge, or the traditional area. It's not a railroad, it's a bike path bridge for Bass River.
Bass River,
Then
okay.
Parker's River, which is a monstrous mistake. When they put the roadway in, they so restricted the flow into the Seine Pond, which is a big salt pond, that merely opening the pond is enough to totally restore it and allow some additional load to go in. I mean,
Okay.
it was really restricted. And those are on Cape, so these are coming down towards you, see?
Right.
And, well, that's 2. I won't.
Okay, I don't want to take up time
That's
now,
okay.
but...
we have them. I mean, some of them have been
perspective,
done.
that would
Oh,
be
I know the
helpful.
other one. The important one is Muddy Creek. I don't know where that is right now in
Right.
Pleasant Bay and Harwich.
Right, okay.
That's a hot one right now.
Okay, thank you.
Good. That's a good. Okay, and I know what you want to do. All right, the framework really for the MEP is we operate under the Clean Water Act. DEP is sort of in charge of these things in the state, with EPA really codifying things and actually providing some resources as well. But DEP is really in charge of its enforcement and also writing the TMDLs with EPA in the review and acceptance mode. So DEP does the heavy lifting on that. The state's required under this to classify all aquatic resources as the highest and best use. What that means for estuaries is when this came out, the municipalities and the state pretty much classified all of their estuarine waters as Class A. There are a couple Class B, harbors and things like that, but Class A. The state has water quality classifications, which tell you what SA, or in saltwater means Salt A, and what that means. And if your particular water body that you're interested in doesn't meet that classification, which would be, for Class A, would be oxygen never drops below 6 ever. So, or there's a percentage, but it doesn't matter. So it's very high oxygen, for instance, then it would be deemed to need a restoration plan. And the restoration plan is called a TMDL, which means total maximum daily load, which means the amount of nitrogen. In this case, since we're interested in nitrogen, that can go in, or phosphorus if you're interested in a lake, they can go into that lake on a daily basis or on an annual basis that will not impair the waters. So if you're under, you can increase it. If you're over, you can decrease it. And then the MEP just provides a scientific basis for the TMDLs for southeastern Massachusetts estuaries. As I've said, we're pushing 70 of them. Okay, well, we know which one's Megantic. Everybody knows where Megantic Squiddig are. All right. We use a modeling approach, but the model is only to refine the threshold. It's not even needed to develop the threshold. I want to emphasize that. what it's really developed for. All that energy goes in there so that the towns can use that to ask what-if questions. What if we widen the bridge? What if we dredge more often? What if we dredge at different times during the year? What if we sewer? What if we don't sewer? All of those types of things are what the model's for, but it's not needed for the TMDL, to develop the TMDL. It's not an essential component of developing the TMDL. But it's an essential part of planning, because otherwise you wouldn't know anything. All right. It's not a push-button model. It's really an approach that involves 4 models linked by scientists and engineers that actually take the data out of one, check it, make sure it's valid, put it into the next one, and also they have to sometimes change certain, they have to do additional reality checks. The watershed nitrogen loading model, which is the model that accumulates all of the nitrogen from the land that goes into the estuary, how it gets there, where it's sourced, what sub-watershed it's in, is actually given out to the towns and always has been from day one of this project. We developed it ourselves, so we had control to be able just to distribute it, so we did. The future access is, if you want to use the model, is just to contact us and we'll work it out. All right, this is how it all fits together. The critical pieces are that really the model is driven by data. It is not it's an empirical model, really. Yeah, there's numerical underpinnings to it, the structure, but really we have to measure things like the tides, the bathymetry. We have to measure the currents. We measure the stream nitrogen load and flow, all of this, the amount of recycled nitrogen. We look at what's in the bay, and we come up with a watershed delineation model, which is run by the USGS, although it's modified in some ways or refined in some ways. For instance, if it doesn't line up right with the coast, you know, because it just, the outer boundary is hard to get, it's going to stop at the coast, things like that. But for the most part, it's about 99% just the mod flow, mod path model run for and validated for the base at JBCC now. Watershed loading model, what we do is once we have the delineation, then we have to add up all the loads that come from that delineated watershed, and that goes into the water, meaning the estuarine water. We have a hydrodynamic model which mixes all the water up with the nitrogen that's in it, and really all the hydrodynamic model does is it allows the spreading of nitrogen as it naturally does within the estuary, which allows us to do things like determine tidally average nitrogen concentrations, because they go up and they go down. When the tide's high, they're lower in an estuary, and when the tide's low, they're higher, and that's just the way it is. And so this allows us to correct for that, correct for the timing of the water quality monitoring that we use to validate it, because not everybody collects the samples at the same time. Okay, and the final thing is the threshold part really just deals with the output from the model, or if we never had a model, we would deal with the output from the monitoring programs that we use that give us the nitrogen distribution in the bay, and we hook that information up with DO and dissolved oxygen measured within the estuary, which is a critical metric. Eelgrass, is it changing? Is it enlarging? Is it gone? In fauna surveys, are the populations of benthic animals that they're high quality or not? Are they impaired or not? Do they reflect, dump sites? Do they reflect the cleanest water? That type of thing. We have all of that data. We use that to come up with a nitrogen threshold, which pretty much comes down to how every nitrogen threshold or phosphorus threshold, but we'll take nitrogen in this case, in the world is done the same way. You end up looking at and determining what, for your region, your temperature, all your tidal stuff, what's a high quality environment, and then you're using that to develop the threshold for your low quality environment. That's how it's always done. There's tricks to it, but that's how it's really done.
Okay.
Don't let anybody kid you. People do.
I just have, can I ask?
Ron. Sure.
Thanks. Thanks. I just wondered, could you just go over the actual sources of nitrogen
In a second, yes.
that are coming in, basically?
I promise I will do it in a second.
Oh, okay. 'Cause I just saw
And if
that.
I don't,
Stream flow.
you can
Okay.
ping me.
Okay.
All right, and then
Okay.
what happens now is when we're done with the thresholds development, we produce these reports, you have the one from Agansett, then really what happens is Mass DEP has to take that, crank it around, grind it up, and end up with a TMDL if it's needed, which it will be from Agansett, and then also, since Mass DEP is a fundamental feature of doing either comprehensive wastewater management planning, watershed planning, whatever you want to call it, that they also use that information as you go forward with your planning. All right. Why does the Commonwealth do this? And I just want to reemphasize this. I don't say it very often, but the reason is that uncertainty costs a lot of money. If we know that there's uncertainty, a large amount of uncertainty in a number, then what happens is that the EPA and DEP and any rational agency would say, well, you have to cover that uncertainty, which if your best estimate is we have to widen the bridge 25 feet, but you don't know, then they're going to say, well, widen it 50 feet, because that's we don't know. If you need to sewer 1,000 homes, but you have this uncertainty, they say 1,500 homes, and the costs just escalate out of control. By getting the uncertainty down in this particular project, we're figuring that alone will save $2 to $3 billion over the life cycle of this implementation project, just because you don't have to overmanage to take care of these wide swings in uncertainty. When we started this, the uncertainty was sometimes 100%, 50, 60 to 100%. So we've gotten the uncertainty down to a level which is acceptable, and it cuts the cost to the communities. All right. The other reason is we come up with a site-specific threshold that's on a one-size-fits-all. A lot of bacterial stuff is one-size-fits-all. What's the number? 14. That's it. Done. For this, we can actually tailor it to the estuary, which also then gets the cost down. It tailors your restoration. And the final thing is what came out of the county peer review, which had national and international experts come in and look at what we were doing, and they said, the MEP modeling approach is appropriate and useful for evaluating alternative scenarios and informing nutrient management plans, and is consistent with existing nationwide TMDL practices. That's the approach that you got. That's the approach that you're using in the alternative scenarios. There's some things that the town of Falmouth has done, and hopefully we'll do many more. All right, there we go. All right. We break this into a couple basins. Obviously, it's all one system. All of this is one system coming out to about a point out here to up here, but we have Squatigue that's highly enclosed basin with tidal waters coming in through the channel, which is we broke out as a separate entity because it operates physically different than the harbor does, obviously, as a dead-end basin. We have the main basin of Megansett Harbor here, but also we have two systems that were previously done, which are Rand's Harbor and Fiddler's Cove. Those were not ignored in this system. They are inputs to this system, and we have to deal with those as well, although mainly the threshold, they have their own thresholds because they're dead-end systems, and this one's a little different. So it has a threshold for these two, and these have their own reports and thresholds, but in going forward, you will have to include these, what you do here, with what happens here, and we did in our modeling. It all starts with water quality monitoring. Water quality monitoring doesn't tell you much about the system. It can tell you if it's good, bad, or maybe bad. That's about it. It won't tell you how much you would be over a limit or under a limit or anything like that, but it gives you the critical information in a distributed spatial fashion that is needed to be able to validate the modeling. It's not used to calibrate, it's to validate the modeling. That's all. That's its use. In this case, we use data collected by CBB in partnership really with the town, with us, doing a lot of the analyses up, not to the end, but mainly to the end, over this long period of time, and we made sure that there wasn't a trend in that. We can't just average it because we have to look for trends. If there was an upward trend or a downward trend, then we would have to not just pull it. But this data was fairly consistent over the course of that period.
Who's CBP?
Coalition for Buzzards Bay. Now it's the Buzzards Bay Coalition.
BBC.
Huh?
Coalition.
Well, to me, the BBC is the British Beer Company, so I have a real hard time saying that. It distracts me. So anyway. All right. The sources and sinks that we look at, the difference with the MEP when we started this was very few people, some were, but very few people were looking at storage. They were looking at sinks. They were looking at nitrogen sources. So everybody would say, okay, well, we'll quantify the wastewater, which could be, could be treated from a treatment plant or could be treated effluent from a septic system. Fertilizers, agriculture, which is both fertilizers and animals. There's a lot more animal agriculture in this region than you think, especially in the vineyard. a lot of the time, and on the other side, there's a lot of it, and it actually contributes in some cases a significant amount. I think in Westport, agriculture is 25-30% of the total load of the estuary, so it's a big deal. Impermeable surfaces, runoff, natural surfaces contribute nitrogen too. Forests contribute nitrogen very little. If we had more forests, we'd have less of these other things, which are big contributors. But you have to count it in because it's a real input. And atmospheric deposition as well. We look at sinks for nitrogen, which failure to look at the sinks, again, you would be over-managing. You'd be estimating that more reaches the estuary than it does. So you have to take out what's removed in transit. And so denitrification of the wetlands, there's not much in aquifer transport. We've done a lot of studies on that with the USGS, and we're not finding it. But surface water ecosystems consume nutrients and remove them permanently from the overall watershed transport system permanently. And well withdrawals we have to account for frequently. What happens, they come up out of the well and they're distributed within that region. They go back into the ground anyway, so we deal with that. And storage isn't much for us, but what it really is, has turned out to be, is that if let's say a treatment plant had a land disposal, 5 years travel time from the estuary, you just built it and you turned it on and you started the disposal today. Well, it wouldn't count in the watershed load of the bay for 5 years until the plume reached the bay. And so that would be counted as storage for us because the nitrogen's there, but it's in the aquifer. It's still being transported. So we have to account for that as well. So we spend a lot of time looking at to make sure that what's been discharged to the land really should be in balance and reaching the bay. Otherwise, again, you're overestimating.
Right.
Yes, sir.
Yeah. Thanks, Eric. I just have a couple questions, Ryan, on the last slide.
Oh,
Hang on a second. You discussed
sorry
this one.
about that.
In terms of when you say wastewater, that really means groundwater for all intents and purposes, right?
No,
So-
if there's a pipe, like in New Bedford, which we did, or Fairhaven, then we have to count that pipe.
Okay, all right, so it's wastewater.
Or in
and-
West Falmouth.
And groundwater as well, right? Groundwater is like.
If it
the
goes into the
septic
groundwater, we
tanks.
count it, and if it goes through a pipe in directly in the bay, we count it, but they're counted differently.
Okay, I just thought you didn't mention that there. Then on denitrification, and this gets into, again, back to the groundwater issue of the septic load coming in. Have you evaluated or measured actually nitrogen loads coming
We've gone,
out?
we have, what do you mean coming out? You want to know about denitrification, or you want to know about nitrogen loads coming out?
No, what I'm trying to, yeah, basically the nitrogen loads that are in the groundwater coming out. Have you actually measured those? We've done some.
Let's do it a different way. What is it
Yeah.
you want to know, rather than telling me how we should measure it?
No, I'm just asking, okay, first of all, have you looked at denitrification in the groundwater?
Yes, we've published multiple papers on the lack of denitrification in groundwater system as long as they remain aerobic.
Okay.
If there's a sufficient organic matter in the groundwater to consume all the oxygen or most of the oxygen and still be organic matter left to reduce the nitrate,
Right.
then yes, we can find it, but that's a very rare case. Most of our groundwaters are fully aerobic, unless you're right, under a septic tank or a cesspool.
And
They're fully aerobic. Your leaching field for your septic system, most of it is fully aerobic because it's got 5 feet of unsaturated zone, which actually is sufficient to keep oxygen in it.
And at the freshwater, saltwater interface area down near the bottom of, or coming
Yeah.
up, is that also aerobic in that area?
But that's also not really where most of the flow is. That's a relatively low flow zone because it's at the bottom, and also that water that's down there came from the highest part of the watershed, which is usually where there's no loads.
Right, but it rises up, right? as
I know
it-
that,
Yeah.
but I'm talking about where it comes from, because where it comes from tells you how much nitrogen is going to be in there. Now, we have looked at septic system loads, transport through the aquifer. We've looked at denitrification of large plumes through a variety of things, and I mean, we've done a heck of a lot of work on this. The one thing that we did is we chose that it would not be reasonable to try, because other people had tried and failed, to try to go probing around the edge of estuaries. So what we did was we found that because it's so highly variable, and the big problem there is distance, because when you go down at the edge of an estuary, when you're down a foot, you're measuring water that came from the shore. When you're down 2 feet, you're measuring it that may have come from 1,000 feet inland. So therefore, slight variations in your sampling protocol, you're sampling all different areas there. You have to capture all of that. And it's a real problem. So what we did to validate all this stuff on multiple occasions, we went and we looked at streams, groundwater fed streams, where 100% of the water in that stream came from groundwater. We delineated the watershed of that stream, and then we calculated the load into that stream, and then we measured it in winter at night. When there's no photosynthesis, it's night and it's winter, it's cold, so there's hardly any denitrification. And that matches. So that's how we knew that the watershed loading model was correct. Okay. More than you wanted to know. So the Megantic-Squatigue has had its watershed delineated. The first thing you have to do is figure out what land are we worried about. And so this is an aerial Cape Cod Commission regional policy plan. They've had several of those, and they have one that includes Megantic and Squatigue. And those two are, the boundary to those two together is this blue line here. But we also have done Rand's and Fiddler's Cove, which is this, whatever mauve or whatever color that is line. And then they didn't put them together, we put them together, but it's not bad. If you look at the lower one, you'll see that actually in many ways and in many places, there's not much difference in the outer bounds of these things. Part of the difference up in this region was new information from the base and the survey and maybe the town of Sandwich on where the watershed divide really is now for this groundwater lens. And so that led to this change. This changed all up and down here because it's actually slightly in a different place.
Farther north and farther east,
That's
right?
it. You're better at this than I am. So, not being facetious either, I couldn't remember whether it was farther north. But in any case, you get...
also to the southeast at the elbow. Like the point has moved northeast.
Well, the mound...
But the closer the bend is
There
actually
is
bulging this way.
more
from the
bend.
southeast.
Yeah,
There's
more bend
It's
and
more
it
like
goes
a
higher.
J.
Yeah, that's right. So what we also do is for our work, we need to have sub-watersheds. So we have sub-watersheds in here so that we can look at like this region here that discharges directly to the coast. And, we have a watershed to Squatigue, but it includes these two internal watersheds as well. And we also are worried about the, for instance, as you'll see right here, I think. No, we will in a second. But this is a blow up of the lower one. Not much difference, and we build on their data. We didn't get all new data. We built on what this Cape Cod Commission had and new data that came in. That's the beauty of this stuff, is that we can just continue to build and refine. It's more of a refinement than anything else. There's two things, by the way, that I should say here. The town of Falmouth is blessed, as most of the towns are that border, especially on this side of the bay, border Joint Base Cape Cod. And the reason is once you get above 28, which is running around here, it's Joint Base Cape Cod, and there's not much development at all, and most of the development's hooked to a sewage treatment plant, which discharges outside of this watershed. So there's not much, as you'll see, development up in this region, which means that variations up in here don't matter so much because there's no load. It's just a water thing.
Could you back one, please? What's that squiggly red line that's
Oh,
perpendicular?
yeah, no, that's fine.
And
The
then there's one
squiggly red
out.
line here is the 10-year time of travel. If you
Oh, okay.
put it in
Yeah.
here, it gets there within 10 years. If you put it up here, it takes more than 10 years to get there. Thank you. That's it.
And I think you should also mention, this is sort of unusual for many of the watersheds that we've seen, that it has wells and extraction, and that's what those
Yeah, these
more
things are
yellowish
wells,
things
yeah.
are, that affect your overall calculation.
And we have to account for the water withdrawals from those wells, both in terms of volume and in terms of our best estimate and the data that's available of nitrogen that's in that water. It's not much.
Not much. No.
Okay, so we then do this, and this I think is somewhere up in here is the LF1 plume, but I'll show you that in a second. We do this, then we use these watersheds as cookie cutters to cut out the parcel data. And this is the parcel data. These are should be individual parcels shown here. In any case, we do it on an individual parcel basis. Each parcel has a registration. Each parcel, 93% of them or 92% of them have metered water data. They have a meter going in. I know what it is. 90% do, 10% don't. The 10% of the buildings within this watershed that don't, we use then. If we can get their well data, we can. If not, we just spread the 90% based on the land use type. So like a residential average for the 9 homes that have water meter data is used to get the 1 home that doesn't. And that's where, we do that all, that's our standard procedure. It's pretty good as long as we're getting like 10% don't. It's not much change. And we break it down into different the parcels into different uses. We're really, in this area, we're looking at, well, the number 1 land use is government use, public service, which is this gray area, which is Joint Base Cape Cod, which doesn't really contribute load, and is one of the reasons why Megansett and Squatigue, and even Fiddlers and Rands, but really Megansett and Squatigue are in really pretty good shape. It's not that we're brilliant, it's just that we happened into this no load area. Right? Now there's other problems with that, but there's still, for nitrogen, it's pretty good.
What's the gray to the left of 28?
This.
No, to
This?
To the left.
left.
I can't tell you what parcel that is right now.
Public service.
It's public service use, but I don't know what it is.
Substantial.
It's the parking lot
Yeah, for
for the Steamship Authority.
Okay, good. And we go in, we do the, the aerial photo work too, so we know what it is, but Ed's not here, he's in Vermont having fun. So anyway, and he does most of this work, or he's in charge of it. Okay, the one thing that's also different, Virginia pointed out the wells are different. These are the wells right here and here. But also we have the landfill 1 plume from Joint Base Cape Cod, and there's a well extraction fence, extraction treatment and reinjection fence here. And this, though, breaks through, and this is what we were worried about, which is the LF1 plume, because it is a landfill. Landfills do have nitrogen in them, and there is some data from this plume. It's been mapped, but we also have some nitrogen data from it. It's weak. It's not great. It's one of the areas that could improve if you had the energy. Because right now, when we originally did this, the load was like, say, 400 kilos. When we just did it, because it's much wider plume and everything, now it's looking like it might be 800 kilos. But I'm thinking it's between 400 and 800 because I don't see the load going up. So, but that's what we have to stick to our thing. I'm pointing it out because it's a weakness. There's no way to get around it without new information. Okay, so who knows? If you knock it from 8 to 4, then all you ever 400 kilos, you can do anything other than get better data from here. And I think that's possible. On your planning horizon, I think that's possible. Okay.
Just one more question. On Squatigue Harbor, which is really feeding into the Falmouth area, it's not in Falmouth, but what is the, on a volume basis, the turnover rate of water based on freshwater inflows per year?
The freshwater inflow data, the turnover in all of Falmouth estuaries pretty much, I'm sure there's an exception, but don't make me do it, because all of the basins, the freshwater turnover is not really that important to the flushing of the systems. And you can say, well, how can that be? There's all this fresh water going in. Yeah, but the basins are almost all of Falmouth estuaries are 24 to 30 parts per thousand. Seawater's coming in about 30, 31. So freshwater's not really doing much. It's a seawater system, which means that it's really tidal flushing. Now, if the salinities were 10, it would be different. We are studying estuaries in South Florida right now that are like that, where freshwater really does make a difference during the wet season. Okay, we go through all that, look at all those individual parcels within their individual sub-watersheds, and we create these pie diagrams for each one of those little sub-watersheds, right? But that would take forever. So this is a total loading to the overall Megansett-Squatigue Harbor system, and of the total load, what we have is about 56% is from septic. There's a large water sheet with atmospheric deposition on it, and that's mainly where atmospheric deposition plays in this. When it falls directly on the estuary, there's no chance for attenuation. And then you go through, this is impermeable, this is the landfill. But that's the total. We can't control the water sheet. We can't control natural surfaces, we can't control the water sheet. There's a natural surface thing in here, that one. And we just can't control that. So if you're looking at trying to manage the system, what are the items that we can manage and what's the breakdown of those? Well, when you take out the water sheet, you take out natural surface, other things we can't control, they're going to happen whether we're here or not, and happened before we were here, in fact, then what we get is just it blows up the numbers, that because we've taken some out, the percentages, and it just refocuses the mind on what are the human sources to this system and where are they coming from. Not to ignore that natural sources are important. Yeah.
No, just again, on the water sheet, you may be aware that in Falmouth, we've passed a nutrient control bylaw. It's a fertilizer control bylaw, right, which might very well impact that, right? So that is somewhat controllable in terms of...
Well, fertilizers are controllable, and that's what
They've
you're
got their
trying
own
to
category.
control. That's fertilizers.
Oh, okay, fertilizer,
Right there.
Okay. Oh, I see they're there, okay.
Yeah, I think you should clarify what you mean by water sheet. It's an important concept, but not
The
everybody
open
gets
water surface
it.
of the estuary or marsh. It's the natural surface. Case of Squatigue, it's when you stand on the shore and you look at all that water when it rains, gets rain on
It's
it.
the rain.
And
It's
that's
the
the
rain in the
rain
atmosphere.
on that water.
Rain.
The nitrogen in the rain. We got it. We got it.
Deposition.
So,
There's nothing in the budget for giant umbrellas.
no. And besides, you
Has to
couldn't
run
get a
off anyway.
tan.
Maybe we need a
Run off
dome.
anyway somewhere.
All right.
All right,
Is
well, maybe
there
we should-
some,
Yeah.
Brian, is there some deposition even without rain?
Yeah, we count wet
Absorption.
and dry deposition. There's dry depositions.
Yeah.
So it's just sometimes hard to explain that. Okay, so then in addition to all that kind of loading information, we also look at development potential. In other words, what could happen maybe. And our development potential is very simple. We look at the present zoning, we look at the watershed. Sometimes if we get input, actually every time we get input from a town about what they think is the likely, development, then we'll use that. I mean, there's sites, what sites are available for development. Town planners know a lot more than anybody else about that for their own community. And the answer is that then you build them to their zone use. All right? Now, if the town goes in and just buys some big parcel, like buys that parcel, fine, then that would not happen. And that's part of the problem with doing build-out, is that you can't predict what's going to happen. There's a heavy amount of land purchases on the Cape for open space and such. Every time those are purchased, then the development potential goes down. And so then any build-out that was done based on that being a developable parcel goes down. And that's why we always say build-out's a fantasy. We don't know what it really is. But if we stick to the definitions we have, the present nitrogen load to this system could increase by 26%. Okay, and part of that is sort of false in the sense that there's so little load going in now on an absolute scale that any little increase is going to be a big percentage, right? All right. We also do checks on the watershed and also loads on the watershed. There is a stream, a gaugeable stream coming into Squatigue through. It empties from Cuffs Pond, which is up here, enters into this area here, and it carries with it fresh water. It also carries with it a lot of nitrogen.
It does.
Yeah.
You're saying it does have a lot of nitrogen in
Yeah,
it.
it's not huge, but it's carrying a load into a little tiny enclosed basin that's attached to a bigger enclosed basin. You'll see the effect of that. The reason I point it out is you'll see the effect of that. Also, what we have to do is we have to know the shape of the basin in order to do the numeric modeling. So we actually went out and we did a bathymetric survey, fathometer survey of this system, and this is now the updated survey map. There always were charts, but this is now the new bathymetry map to the system. And what you see from Agansett is there's a hole. And what you really see here is coming off of these things that goes down a hill into the hole. And that's important to how we view this whole system. There's eelgrass up in here, there's eelgrass up in here, up in here, and there's a hole. And the reason I keep pointing out the hole is because that's a natural depositional basin. It gets material deposited in it. There's nothing we can do about that. And if you lessen the phytoplankton in the bay a little bit, then it will decrease. but pretty much it's a natural deposition basin. Squetique is shallow enough, that's not the case. Squetique is quite shallow and mixes from top to bottom. All right. All right, now getting back to our discussion of flushing. First thing we do is we look at every system. We look at the major basins. So outer Megansett, which I also call the main basin of Megansett, which is where the hole is, and that other areas around. I'll have to go back a second. Oops. This whole thing here is outer Megansett, or Megansett Basin. This is the channel, and this is Squetique. And we put tide gauges in, and they're all to a single datum, and so we can cross-reference them. And when we do that, what we see is the outer Megansett, the inner Megansett, which is the channel, and Squetique Basin, there's 3 lines there in all cases. There's 3 traces, and there's just no difference between them. And outer Megansett does not have any blocked circulation. It is not tidally impaired. So the point is that if everything matches it, and it is not blocked, then it means that the other ones aren't blocked either. So we're not going to get any bang for the buck out of trying to dredge the channel or do something like that. There are things that might happen someday, but I don't think they're permittable. Okay. So that's the cross-check on the hydrodynamics. The next thing we do is we create a hydrodynamic model, numerical model, that simulates the tides. And we do that, and then we compare it to measured tides. And they're measured tides that weren't used in the modeling effort. And there's 2 lines here, and there's 2 lines there. Suffice it to say they fall on top of each other again, which means that the model is very accurately simulating the tide. If it simulates the tide, it's simulating the flushing. All right, this is a little tougher to do. This is the model number that we had for one day that we did recently, November 11th, 2014. We went out and did it again just for fun. And the critical piece is, if you look in here, the blue line, which is the modeled line, and the dots are measured flow. Now, it's really hard to measure measured flow. It's also, these spikes are tide gauge problems, but we have to use them. And in fact, it's not a problem because you notice the ADCP went up. So we measured the tidal flow volume, and we modeled the tidal flow volume, and they match really well, especially up in here where there's none of this wind shit going on. Pardon me, I didn't say that.
Steve,
Yeah.
if you compare Squetique
Yeah.
to the south coast estuaries where
Yeah.
inlet widening
Yep.
has been considered, or is being considered or not, what's the key difference in geometry? Is it the volume to channel cross-sectional area ratio?
No, it's the tide range. You have a
Tide
huge
range.
tide. You have a
Bigger tide on Buzzards Bay?
Yeah, 5,
Yes.
6 feet.
Yes.
And then right in Little Pond, for instance, it's 45 centimeters, so it's 1.5 feet. Because the way Nantucket Sound dampens the tides. You get a tidal signal coming in from the east and one coming in from the west, they dampen it out, and you get a very small tide range along some of those ponds, like Little Pond and Falmouth Harbor, but certainly Green Pond. Okay. All right, then we have to give you the assurance that actually the thing works. And so what we do is we go and we calibrate the water quality model using salinity, where we have salinity data from the monitoring program, and at these sites, these are the sites that you'll see in all the reports, and then the predicted based on the modeling effort. So the modeling effort says, okay, there's this much, this is the salinity of the water offshore, this is the fresh water that comes in, and this is how the tidal circulation goes within the bed. That's all that goes into the model. And then you say, okay, tell me the salinity distribution in the bed. And these numbers pop out, the blue ones, and the red ones are the averages of the monitoring data, okay? And if data is collected closer to low tide, which this is, then what you see is the red dot will be, in this case, up more towards the top. That is low tide estimate. That's the high tide estimate. But these data were always collected. They weren't like pond watchers collected at mid tide. These are collected closer to low tide. Okay? So we have to account for that. For nitrogen, which is our primary thing we're interested in, we have a pretty good one-to-one fit, although you can't hardly see the line here. I'm sorry for that. I apologize. But really, we have a very good fit of the measured and modeled. And remember, to get this, those blue dots on the left, You put the nitrogen loads in, all those different loads, you distribute it spatially as they really exist. If they come in surface water, you put them in surface water. If they come in groundwater, you put them in groundwater. You put in the benthic regeneration data, you put in the atmospheric flux, you put in all those sources, you mix it around and you say, okay, tell me what the nitrogen distribution is. Those are the blue dots. And then you say, okay, what do we get out of the water quality monitoring program? Those are the red dots. So it does a fairly good job at approximating, the nitrogen field, and that gives us confidence. And again, closer to low tide, just like the salinity, so it's going to be the triangle and the triangle more than the bottom and the bottom, or the mid and the mid. We always have that problem with different programs. We have to find out exactly when they typically, what their QAP says they're supposed to be measuring the samples in. It can make a big difference. All right, put it all together and you can then develop these gradient maps of nitrogen. And for this one, we can animate it, and this is a couple tidal cycles. And what you see is that Squetique is not really super flushing out like anything super good here.
Although there is some.
Oh, yeah, and you can see it'll come in, and once in a while, because the tides are asymmetrical, I think some of them, you'll see something in here coming, see? I'll do it again.
There's no point in trying to widen anything because the tidal prism, that's,
Well, there's no blockage, yeah.
there's no blockage.
But you can
Right.
see it does penetrate in, and,
Yeah.
and we're suffering from the coarse, not the coarseness, but just how the colors are. I mean, we can't put it every hundredth.
But as I recall, when I read the written version of this report, the only problem in this whole area is that little nook. in
Yeah, they're
Squetique,
over in
right?
here, but
The rest is
up in here
acceptable.
too, though. Up in here has some issues as well.
So then my question is, yeah, inlet widening won't work, but
Right.
what if you put a conduit in the west corner with a one-way valve?
Here,
Yeah.
you mean?
Yes.
Yeah, that was when I said that, yeah, well, there's some things you might think about, but you'll never get a permit. That was it.
Maybe the hurricane will wash it away.
Yeah, I mean, get a hurricane. I mean, don't worry. I promise you, we will not be recommending that we go through the barrier, okay? At this point. We got 20 years to argue that one out, and we'll be retired by then.
Steve might.
What, besides regulatory hurdles, what would be the disadvantage of doing that?
I don't know, well, the problem is you can't have a two-inlet system, so now what are you gonna do with this? All of this, because the tide, if you open that up, systems can maintain two inlets if you jetty them, and you keep dredging them, because they really tend to, the one inlet, like if this is a much more efficient inlet, it's gonna steal water from this one, eventually it'll close up. That's why like in Nauset, Pleasant Bay, the inlets move up and down the coast as you get a new breach and it steals the water from the old one. The old one eventually closes up because the new one's more efficient, it takes the water from it.
Again,
So it would be the maintenance cost, the dredging of the dredging.
What are you going to
to
do
keep them
about
both.
this, though? I mean, this
Environmental
very likely is
impacts
going to
don't
want to
like
close
it.
up,
One-way
and
valve.
I think that might be a real policy issue for the town in having this, because then we worry about flushing problems. What about in here? What about this whole channel here? You know, is that going to start causing, if this becomes a dead end, then this is going to become horrible.
But what if you only stole 10% of it? Would that then not be
What I'm trying to
enough?
say is
I
it's
don't
going
want-
to try
I'm
to
getting too
steal
deep
as much
into the
as it
weeds,
can.
but-
It will try to steal as much as it can. You could try to get a culvert in, but you'd have to first do the modeling to see that that would have any effect whatsoever, because a lot of, our strongest part of this is the hydrodynamic modeling. And we can tell you what would happen if you put a breach there. We've done it for Nantucket. People always, at the haul over, they want to know, what if we put another breach in? A lot of estuaries, people want to know, what if we put another opening in someplace? So we can run that model.
so modeling a breach right there.
And it's not always good. In Nantucket, it's not good.
How about a culvert up on the upper right-hand, the right-hand side, right there?
God, we're really in sync, aren't we?
There?
Yeah, I
that's
mean,
even better.
these are the things that you can look at. There may have been one even there once. I don't know, because there's a roadway out there on a causeway.
Yeah.
And if you look at how it's pinched off, it makes you wonder if that was open, they filled it and put in the road and didn't put in a culvert.
Right.
But what about the advantages or disadvantages of doing it?
We don't know. We'd have to run. I've gotten smart enough to know not to predict what's going to happen if you put another hole in the.
But you don't see the same obvious disadvantages as you do for the one over in the west corner.
No, I think this might even be on private.
It's called Amrita Island.
Yeah.
It is in Bourne, but I agree that we should at least take a look at it. Well,
Well, it's in
we
the
as
interest of
Bourne.
the landowners because it affects their northern beach.
Yeah, well, it'll be nicer.
Yeah,
I would say that it's cheap. It's a lot cheaper than going trying to permit something. You first ought to know, is it worth it? And
well,
that's-
obviously, if it had been filled before,
Yeah. Yeah.
because it's called Amrita Island, it could have
Oh,
originally.
yeah, right.
Right, could originally have been.
Light shines on
I
Marvin.
mean, it'd still be a regulatory decision,
yeah.
even if it's
All right.
private land.
It's
Absolutely.
also
Okay.
in Bourne, not in Falmouth.
Well, yeah, that's right. Okay, so where we're at, though, is you get an idea, is that when we change this color scheme a little bit to heighten them up, what you're seeing is you see these, especially under build-out, which is really your planning horizon, it gets very bad up in here. Because you increase the load by 26%, flushing remains the same, and the higher nitrogen levels actually start penetrating more out into the outer harbor region, but not much. I mean, this is the blue, and it would be blue every place else. But this would be bad because the eelgrass beds are up in here, okay, and down in here. And if we start seeing higher water quality, that's really going to be bad. So, whereas a lot of this is in pretty good shape today, if it goes to build out, it won't be. All right. As I said, our thresholds that we do, we look at real things you can measure, see, touch, like the auction records, the eelgrass and macroalgae, the benthic animals, and then we look at long-term water quality records. I left this in this way. This is the DEP from Charlie Costello. He provides these for all the reports. And the problem that we have with this particular system, and we've had it with other systems, I think, I don't know whether it's Tisbury, Great Pine, or Chilmark, but we've had the same problem, which is that if there's no evidence that supports like that thing in 1951 that's supposed to be inside Squetik, if we can't find any anecdotal, any reports, any shellfish reports that support that, we can't then make the communities, in good faith, you cannot make the communities restore Squetik to get 1951 eelgrass, that we have no documentation that it was there other than there was a dark patch in the 1951 aerial photo. It's just not enough. And this has happened before Hammond and Papaneset. The very first one we did happened in. And what we found was in Shoestring Bay, everybody was pushing, EPA was pushing that we really should restore Shoestring Bay for eelgrass. And when we got all done, we found that couldn't happen. That the circulation of the bay was such that that would never get down low enough to support eelgrass, even if all the other eelgrass in the bay was restored. So DEP said, yeah, okay, we get it, fine, good. Yeah, we're on the same page, and we're on the same page. So we have the same problem here in that we don't have documentation. These triangles are actually people going out and looking, and for DEP going out and looking, we have a ton of these because every time we go out and survey, we put in more and more and more dots. But this is what they have, and it's actually pretty good data. And so the data that we really trust in this is when you see multiple contours falling on top of each other, and we also have other data sets which confirm that there's eelgrass. There was eelgrass here, and there is eelgrass there now. But we just can't buy into this at this point. We're looking for justification. Unfortunately, we find it, but we've been looking for 2 years. We haven't found
The
it.
triangles are not just where people looked. They're where people looked and saw eelgrass.
No, they're only where people looked.
So it's meaningless.
Meaningless.
It's totally meaningless.
No, because they looked here and they
But you
saw
don't tell me what
eelgrass,
they
and they
saw.
looked here and didn't see it.
Well, you see where it says the
But what about all the other curves where there are no triangles? Obviously,
Yeah, but
somebody
we
looked
know,
there and it draws
but look
a
at when they
curve.
are, wait, but look at when they are. We have other data that says there's eelgrass here. We said there's eelgrass here now. We went out in 2005, 2007, we went out in 2014. We also went around all these things and did points. And yeah, there's eelgrass there now, and was eelgrass, and it falls in these patterns, and the fact that they see these here, that's believable, that's documentable. And when you have them on top of each other and on top of each other, you go out tomorrow, you'll find it in here.
Well,
Okay.
what's significant, Brian, is that you've got that 1951 extent in the not most impaired part of outer Magansett.
I know that.
And the eelgrass is gone.
I understand that.
Yeah, that's
But what we do is we're not using the 1951 is what you should have heard me say
You said,
5 or 6 times.
but
I'll say it again. We're
Yeah.
not using the 1951
isn't there,
distribution.
there's
because
also
we can't
sort of
document it.
natural succession of these beds in the sense they come and go to a degree.
Well,
Was it 1930 that there was a major
Yeah,
disease?
but we know
and-
about that. We know
Yeah.
why it occurred. We
Right.
identified the slime mold that did it.
Right.
We know when it went away. We know when it recovered. We know all that. This there is not any natural reason for the change in this bed from 95, when it was this big, to 2001, when it was that big, and then to 2012, when now it's this little patch.
If you're not using the 1951 data, I would suggest you not depict it.
Well, our problem is at this point, we couldn't get Charlie to have a redo the map. We put it in.
Okay.
This is a
All right,
draft,
but-
and we'll put it in, we will probably take that to the final, but we never feel that we should be tooling around with other people's data. So what we do is we have to get him to.
What's the date on the triangles? Is that 2014?
Most of the time when these different color things were done. there
No, I'm
were
just talking
field
about the
points.
triangle, the purple triangle.
Most of the time when these things were done, there were also triangles taken. So they weren't done separately. They were done by DEP on the days when they were, in the recent times, 95 to 2012.
But you're not saying what they saw?
If it's inside an eelgrass patch, they saw eelgrass. If it's outside of an eelgrass patch, they didn't see eelgrass. Because if they saw eelgrass there, then this contour would go up and capture that.
So
Think about it.
Nobody's arguing.
Think about
I'll
it.
have
You
to
have
take
your
part of
lot that you have your house on. There's your house, there's your lot. Somebody comes in and says, oh, but you also own this patch over here. Well, then you're going to draw your lot line differently, right? Because you know you own that patch. If they had seen eelgrass there, then that would be included in this patch or would have its own patch. But it doesn't. Since it has no contour, it has no eelgrass by definition.
Yeah, just if I
Go
might,
ahead.
you're all admitting in 1951, inside those red lines, there was eelgrass. I mean, no one's saying it wasn't there, right? It was there.
Well, I don't think, we're not buying in that it was here and here.
Or weren't these aerial photographs?
Aerial photographs, look at this aerial photograph. See this?
Yeah.
It's dark. And so what you're looking at is you're trying to look at fine differences in reflectance, fine differences in the color. It's an imperfect science, and everybody will tell you that. And in fact, I just read one of the 84 sequences where everything was ground truth, and they said, we can't do aerial photos in this system.
Okay, so that is the premise here now, that these 51 observations
This is
or
our
photos
premise, and
were
we put
not
it in the report.
not valid.
And we put it in the report, and
Okay.
we said that, and we would need documentation to change our minds.
Okay.
Just
I
another
don't think
point.
Charlie's going to be promising us to reach.
Yeah, another point on that too is that it looks like, if you look at the southern part of the bay,
Down in
it
here.
looks, yeah, down here, basically, it looks like that there was there's more eelgrass in 95 in some areas than there was in 51. In other words, it's that area there. Also, in 2000, in 95, there was actually, and there was more than in 2001 as well. So it was,
That you would expect.
yeah, that would be expected.
It's-
Right, it's the other one that's.
Okay.
Let me tell you what's important to us. What's important to us are shrinking beds. This one in particular, some of the things up in here when you look very closely at it, but also in this region here, when we have 95, I'm not saying I believe that it went all the way out there, I don't know, but there are validation points there. So I have to believe that there's eelgrass in there to some extent, and there isn't eelgrass there now. So what's happening is forget the red line, again, here, same thing, 95. What it looks like is that eelgrass, the coverage area is shrinking in to shallower water. It looks like that the same thing is happening when you look at the bathymetry, and even maybe up in here, but I don't think so. The critical thing is when you get shrinkage from deeper to shallower, that is a diagnostic feature of turbidity changes, eutrophication changes in eelgrass coverage, because there's less light. So the stuff that could grow in deep water can't grow there anymore.
Okay.
So it's not running away, but it's dying off because it doesn't have enough light to survive. And so you find it now in the shallows more than in the deeper area. We've seen this over and over and over again.
Okay, the 95 boundaries and the 2001 boundaries, those were not aerial photographs, those were somebody looking.
Some of
from
it's
a-
aerial, but
Oh.
there were on-site surveys. Plus, it's not shown here because this is what DEP did. We went out in 95 and we field verified that the eelgrass that's there in between these 2 points, 2001, 2005, because we didn't do it in either one of these years, but those that we verified these sites ourselves, independently with divers.
Okay.
I think the bottom line here is that things are getting worse.
Yeah, and so what we're focusing in on
For
are
whatever
getting
reason,
rid of,
they're getting worse.
getting rid of
Probably.
these, and again, this is from deeper, that's deeper, shallower.
Yeah.
Again, what we're trying to get rid of is this gradual, and we keep emphasizing in this report, it's a pretty stable system, but there's a gradual loss. You're close to the limit, just over, but it's gradually declining, and it's declining in a way that's diagnostic of light loss due to eutrophication. All right, we put out oxygen meters at all these sites, and they're continuous. They're a minimum of 30 days. They sometimes go to 60. And it's kind of strange. This is Squatigue. This is 6 milligrams per liter, which is the classification. We don't really see, and nor does the Chesapeake, if it's above 4, it's not particularly stressful. If it's above 4, these are all above 4. One point like that in a time series data set, we're not going. We've been doing this since the 80s. So these are pretty good for Squatigue. The reason that Squatigue has such good oxygen is because it's so shallow. It's mixed, vertically mixed. So it's being vertically mixed all the time. So it's being aerated. If you stop the mixing, you're going to have real oxygen problems. But you're not going to stop the mixing because most of the points are, a meter deep, 1.5 meters deep, very, very shallow. And it's not like Little Pond, which is narrow and shallow. It's big, wide open basin and shallow, which means that you get a lot of vertical mixing. And so you get oxygenation. Most of our estuaries in this region are stealing oxygen from the atmosphere in the summer, not providing
What
it.
time of day are these taken?
I can't hear you.
What time, what?
I couldn't hear you.
Oh, sorry, what time of day were these measurements
These are
taken?
24. This isn't day. This
Oh,
is
that's
a month.
one day. Oh, one
Continuous.
day, okay.
Continuous.
This is a day.
I couldn't tell the date, so I
Yeah,
see.
these
Okay.
are the ups and downs are the diurnal cycle. Goes up in the daytime, goes down at night. Yeah.
It's too bad it's 2 different years.
Well, they're not all 2 different years. You guys should be happy that we went out and redid it.
The inner was 06 and the outer was 05.
It was 6 and 05, but that wasn't the only times we did it. So anyway, again, Meganthet 1 and is up here. Meganthet 2, those are the 2 that I'm most worried about, 1 and 2.
Okay.
So of course I have 1 and 3. But most of these still, these little departures, and we're re-looking at some of how we classify these things, but this is the data as it stands today, and we're not seeing significant stress to the animals. More importantly, when we look in the animals themselves, we're not seeing much stress. So there's some, but not much.
The low point at the top there could be that you just had some very cloudy weather, heavy days before.
I'll give you a paper we just published that
Yeah.
is on why regional oxygen drops in all estuaries at the same time. Different amounts, depending on the level of background eutrophication they're at, but on the same day. And a lot of Falmouth estuaries are in that paper. That's my other life. All right, so this is where we assess benthic communities. I want to stress, we got worried because 2005 we had done a survey, and we had the time to do it. The town had provided funding for this report in a good way, and so we actually just said, well, we have a little bit extra money, we'll go out and we'll redo all the in-fauna work. We didn't do all of it, we did like 85% of it. We reestablished every station except for 15% of them or 10% of them, and we re-looked at the in-fauna. There was no difference in this system that was a trend line difference between 2005 and 2014. What I mean by a trend line difference is if this site goes up and this site goes down and that site goes up and that site goes down, it's very difficult to see a trend line. So what we did was we were able to say that, and we did the statistics, there were no difference, so we just pooled the data. What you're seeing is the pooled data from 05 and 14. And the system's in pretty good shape. It's what we look at, our diagnostic features, the big ones are the number of species. 22 is pretty good, but before you feel really good, of course it has 30, 35. Upon Bay, parts of it have 30. So 22 is not great, but anything over 20, certainly anything over 25 is looking pretty good. So Meganthet Harbor's not doing too bad. The Outer Harbor, the numbers are fine. The diversity's great. The diversity is pretty good in all of them. And the evenness is pretty good. So that's not the issue. The issue is the number of species. And what we see in the channel, a little bit lower, but we expect that because channels are typically disturbed because of sand movement. We see that all the time. We found it first in Chatham Harbor with the breach. It just can't establish themselves. But Squatigue Harbor, North Basin, which is that upper area, If you continue that island, it was Amory Island. If you go north of that, that's the North Basin. South of that's the South Basin. And South Basin looks pretty much like the channel, but the North Basin is lower. And the North Basin has stress indicators, some transitional species. So the species that are there are reflective of the actual animals present, and who dominates is reflective of organic enrichment. The number of species is reflective of organic enrichment.
Is there some, I don't know anything about this field, but I just think something about the math of it. Is there some standard protocol so it isn't like bird watching? Oh, I saw a blue very.
They don't move.
Blah, blah, blah.
They don't move, that's why we picked them. It would be like bird watching if all the birds landed in a tree and they couldn't move for.
Oh, they're plants.
No, they're animals that live in the mud.
They're like worms.
Worms and clams and,
Yeah, like clam.
Oh,
clams,
okay,
there's some
okay.
clams,
But
yeah.
you still, there's, at the fringes of the curve, which affect the number of species you find.
There's a seasonal
There-
cycle,
there-
it's a whole, yes, but there's a seasonal cycle to this, and when we sample is the time when you would see the impairment. If we sample in November, December, you wouldn't see the impairment because all the young in the year have now set. You go to Perch Pond in the summer, in July, and there's nothing there. Aquay Bay, nothing there. Maybe a couple random guys that made it or got washed in. You go there in December, November, December, all the young of the year have set and all the species are back because there's a source of larvae coming in, but they can't make it through the summer. So that's why we measure this in July and August. It's because then, or actually later than that, I think we sample in the fall, that before the set and after all the damage is done.
So what is like a reference number? What would be like a high, like let's say Quistit Harbor you said was in pretty good shape. Would that be a?
A high number is 30 species.
30? Okay.
A high number here for, like Quistit would be about this, I mean about 250. I mean, that's a good number. You can get a lot more in numbers, but high numbers don't mean anything because it could be all capitales, which are all these high stress indicator species that are high indicators of horrible conditions. And they're little tiny little things that, they reproduce fast and leave an ugly corpse. I mean, that's...
But the number 30 is related to species rather than, the number 30.
Number of species.
30.
Related to
Yeah, it's
species.
just number of species.
Species, okay.
But we also look at the number of animals, so
Yeah.
like down here, some
Right.
transitional species, amphipods. So
Right.
we see amphipods, we see some other organic indicator species in this system, and those are diagnostic. That's like, looking at fish, and you look at the pond, it's all catfish. Is that a great, oxygenated deep water, cold water fishery? No, it's not. It's all catfish. So if you see all smallmouth bass, that means something else about that pond. So you can do that, and this is a pretty well-heeled, ancient, not ancient, but ancient enough field it's pretty firm now. Okay? Especially in this region. All right. The overall habitat health for the system is if you take the outer basin, the oxygen is a little low. I mean, it gets down right around 4, and that's a little, but it's still healthy. But it's right on the border. That's what that means. Same thing in the channel, same thing in Squatigue. It's somewhat depressed, but it's not enough. It's just not enough to go crazy. The chlorophyll levels are fine, except in Squatigue. Normal levels, you want them to average around less than 10. And the average from our mooring data and from grab sample data for Squatigue was greater than 10. If it wasn't high, it was 12 or something like that. But it's still elevated. You don't see that in Buzzards Bay, might get 3 to 5. So you see in 12 that is elevated. It makes sense. But Narragansett Harbor's wide open, the channel's pretty good, and so nothing there. Macroalgae is really indicative of bad, stressful conditions, and we don't really see any. We saw a little bit in the channel and dead spots, but nothing, again, to really worry about. This system is very good for macroalgae right now. Eelgrass, there wasn't any documented here. They're not documented there, but we do have it documented in Narragansett Harbor in spades. And what we see is we're reading the maps as showing some form of decline. Not a lot, and we stress that, not a lot. But it is in a couple places. It's not just in one place, which is good. And so that, by definition, even if everything else was high quality, the loss or gradual loss of eelgrass, by definition, has to classify the system as impaired for eelgrass habitat. If everything else is great, unless you can't back it up that it's from nutrients, but and this is consistent with nutrient overloading, but the definition is if there's eelgrass there and it's diminishing, it's moderately impaired. If there used to be eelgrass there and it's gone, it's significantly impaired.
Just one other thing, on the mooring situation, I don't know what the situation is there, but is there like, with the chains creating all those circles?
On the boats?
Boats,
I'm
yeah.
not worried about, because where we're seeing eelgrass loss, there's not.
There's no.
I'm not saying none of the places we're seeing loss,
Right,
but
right.
but we're seeing loss in places where there are no boats.
Right.
And that's one of the things we look at. We look at moorings, we look at shellfishing, look at a variety of other things that might cause those losses. Okay, and the animals are not doing too bad, but again, it's Squatee, where that was at North Basin and Squatee. See, the South Basin is healthy, the North Basin is moderately impaired, so that's where you get that. And that's sort of where you get these two, the slashes. So that's where it is. So you're not going to end up with anything different than these down here for the summaries. We're just trying to summarize them up in a rational fashion, that because you have H's and MI's, and by definition it has to be MI, but this one still has a lot of high quality habitat. So it's impaired, but it's not a lot impaired. It's just getting impaired, okay? That's a very hard thing to put in a table. Okay, so what's the status? In blunt words, without all the qualifiers, the outer basin is impaired for eelgrass because it's declining. Not a lot, but it's declining. The inner basin, which is all Squatee, is impaired because its benthic animal habitat is showing signs of nutrient impairment. Clearly, it's nutrient organic matter impairment. No question it's not that it's something else, it's that. And it's moderately impaired, which is the lowest level of impairment. So the restoration goal obviously would be to repair those habitats. This map, that just says that's a blow-up refinement on the present and money distribution. And then,
Brian, if instead of my silly idea or the other idea of putting culverts in.
Oh, I didn't say it was silly.
Well,
Don't.
Well, I'm just. No, I'm not
No, but I want you to know that.
Okay. If instead of doing that, you brought the red and orange area down to acceptable by reducing the input load, would that also fix everything else?
It may not fix everything else, but that would be the steps that you would take. That would be a big part of the solution. And the reason that this thing comes across here too is the way the circulation of the basin goes. You notice it doesn't do this. It does this. And the reason is that there's shoaling, it's the shape of the basin. So it tends to hold the nutrients in this area.
When comparing this range to the South Coast estuaries, our target is like 0.45.
No, this is correct.
Right, so this is, I mean, up at 0.5, but throw a few shellfish in that area, and maybe that would
be
get it into 0.4. I don't know, we'll see what your TMDL is. Okay.
All right. You don't have to lower it much.
Yeah.
And it's funny, because we had this problem one other time in Nantucket. I think we had the problem maybe in Phineas Harbor. Because the thing is that it's just over the limit. It actually takes some real load reduction from the watershed to get that down that little bit. It seems like a little bit, but it's actually a little bit in a lot of water. So it's actually a pretty good amount of nitrogen we're talking about here. But when we see 0.355 nitrogen, we're seeing eelgrass decline. So you can't leave it at it's only like 0.358 or something like that. So there's a range out here. And so you can't leave it where it's already declining. So, and we know from West Falmouth and from a variety of other places, Quissit has a weird one too, it's like 0.34. And it's just a little bit lower just to bring it back a little bit because it's just barely over. Still has eelgrass, still has some good healthy benthic infauna. You just have to knock it back a little bit. This is a place where I wouldn't start running around thinking out the sewer everything. This would be a place where I would be thinking about what else can we do because it's just a little bit. And Ron's thing, I blew him off on the shellfish, but things like that or other things like culverts, things like that, those are the types of things really the town should look at for this. And I got one more thing to say about
The present
this.
load is the present load, not the future.
Right, and it's under present loading. Under future loading, then you get a problem.
But the culvert doesn't fix the outer areas. It just lets
No,
the nitrogen
it
get there
would get out
faster.
there quicker, yeah. It would not repair the eelgrass. Okay, so we run, as you know, we run thresholds. We used to just say, well, here's a threshold example, but really what it's turned out to be is we want to prove that you can hit the threshold. If it's a crazy threshold for some reason, then we want to make sure that you can hit it. And in this case, we said, well, okay, let's say we're just going to do septic reductions, just septic. What it would take for Megansett Harbor watershed out here, this basin It's really, the truth of it, it's this watershed here, which comes up into here. It would be a 25% reduction in just septic, nothing else, not stormwater, not anything else, just septic. And it would be, for Squatigue, only a 10% reduction, which Squatigue includes, for this analysis, this statement, it includes the channel. So it's a very small, it's actually a very small reduction. And the reason that we did, and you could do it anyway. You could lower Squatigue more and Megansett Harbor less. You know what I mean? And this is done independently of restoration plans for Rands and Fiddlers, because we have no idea when you're going to do that. And the scenario that we might want to run in the future would be, well, what if we restored these two first, lowered the load into these two first, then what does this 25% become? It would become like 20%.
But you might also want to point out to people what that diagonal brown line is.
The brown, oh yeah, it's a town line. I know those lines. And so the point is, there's a couple ways that we would discuss with you that refinement, sneaky things that you can do in here that aren't apparent unless you really know the guts of things. And so there's a couple scenarios that we would suggest now, having finished it. They're not important to this TMDL, they're not even important to this report, but if you were decided that you were going to do this first, then it would become important.
Could you go back one?
Yes, sir.
Would it be fair to say that your biggest bang for the buck might be to attack the dark red and the yellow spot first?
Well, it's going to be to attack Squatigue to some extent in general. This, remember, is because there's a stream coming in, but also it's very difficult sometimes. You can't trust contours perfectly when you get into small spaces. Do you know what I mean? It's a modeling artifact. This isn't an artifact. I mean, there really is a load coming in here, and that's why that's red. But you would, if you could lower the stream load, that would be great. But to restore Squatigue and out here is going to take the greater watershed as well, because there's just not that much load here. It's because there's a load coming into a very shallow, very small, and also not that well flushed, a little tributary thing.
Kind of like Fiddlers.
But you did say before that if you took that load out,
It would be good.
it would be good everywhere.
It would
Because that's
improve it
where a lot of,
everywhere.
that's where
No,
it's
it would
coming from.
improve it all the way out to here.
Yeah.
But it wouldn't improve it all the way, we don't think. See, I can't tell you what, sitting here, a change that you want to do is going to have the effect unless, say, what if we move half the load? Well, that's going to work because you don't have to remove that much. You only have to remove like 17% in it, and that which is equivalent to 25% septic. So it's not much load. The question is, I don't know how much load that is.
Is that load almost entirely coming from Bourne and Sandwich, or at least not from Falmouth?
Sandwich doesn't do too much because most of it's on the
It's
basin.
Bourne.
So
It's a Bourne issue. It's more of a Bourne issue.
A lot of that's the plume that Brian talked about.
yeah, a lot of that too would be that captures,
That
I think.
400 to 700 kilograms is absolutely what's not captured by the treatment of.
So do the feds have to pay for that?
Is going
I
right
think
into
you already
the
got
sea.
your bite at the feds, but we could try. I don't think it's going to happen.
One could try.
I think $1 billion was enough.
And the stream, just so you guys know, that stream is contributing, according to the report, about 50% of the total nitrogen.
50.
50 is coming in from, is it Cuffs Stream?
Cuffs
It's called a
Pond.
pond.
Cuffs
That
Pond.
load is, according to the report,
Alright.
half of the load coming in there.
And that relates to the base plume?
No,
they're two
no,
very
no.
separate
This
separate
is a natural
sources.
discharge.
Okay.
It's like Coonamessett River.
Exactly, so that's
Okay,
that's
so
the
what's going
stream.
on in Cuffs Pond?
Well, it's the whole residential area that contributes to that stream as it comes out of the pond and then
Gotcha.
ultimately reaches the basin.
That's exactly right.
Okay.
But we can-
I can go through the numbers on that. Just, it's one of the reasons we measure the streams directly. Okay, so in any case, system's in pretty good shape, little impaired, not much nitrogen at this present date needs to be removed to restore it, whatever mechanism you choose to take. And because it's so small, now this is one of those systems where when it's that small, then things that we would say, no, don't do that, because it's crazy, become okay, because it's so small.
Chair, it's,
Yeah.
if it's 25% of the septic load, by the numbers in the report, that's about 500 kilograms.
500,
Yeah.
500
Which is,
kilograms.
again,
That's a small number.
but it's also why I'm banging the drum for trying to get better numbers for the LF1 plume.
Of course, Dan
Because-
Ward has 20 acres of, what is it, 20 acres of oyster grant out there?
True.
But
That's in the outer.
In the outer.
Right,
Oh,
right.
too far away.
I know.
But it
But
does
it allows
relate,
the
I
flushing.
think that's a really interesting point, Ron. I was
Yeah.
thinking the same thing. If fiddlers and rans are contributing, one of the, I think, a really valuable model run would actually be understanding if we did, as Brian just pointed out, if there was some fixing of fiddlers and rans, how would that affect the whole system?
it'll have a big effect, in fact, on the whole system.
Good.
And that would mean that oysters out there could also have a big effect because it's part of the same basin. So that's a very interesting. But the numbers that he's got, because they're recent and because the grant is recent, includes the oyster effect that's contributing right now. So that grant is already out there.
But whatever you do in those places, you still have to fix that red area.
Yeah, but it goes away if you start removing load from up there,
Because it's a flushing.
you know what I mean?
Yes.
So, and remember that whatever the load is, actually, I'm actually gonna contradict myself. If the plume all goes to that point, that cuff stream point, the LF1 plume, if it all discharges through that point, it doesn't matter what the plume number is, because we measured the load. So you may be able to negotiate something because you're getting a lot of load imported in. You may be able to say, well, it's going to go away at some point, so therefore, let's just let it naturally attenuate out of the aquifer because they're not putting it in anymore. There's management decisions to be made, but it wouldn't change the load to the harbor because we use the measured stream load.
Right.
And now that's a question. I would have to go back and look to make sure that's a true. I mean, my statement's true.
Yeah, I didn't know the landfill plume actually welled up into that stream.
I didn't either.
I'm looking
I-
at it here. and I'm not
To me, as I remember, that landfill plume is so depressed into the groundwater table that it's actually coming out in Squatigue Harbor. It would be underflowing this stream. It's just a fact that would have to be changed.
Yeah,
checked
but we
out.
wouldn't have to, we went and got the map. We got the plume map and everything. And it fits inside of our thing. But I just can't recall it off the top of my head.
Sure.
Remember, this is getting down and really.
Right.
Well, it's one of the
Yeah.
things we'll check
Right.
out between draft and final.
I want to inject here just for a second. That at least two people have something elsewhere to do at 11 o'clock. So
Me
the
first.
intention of the chair would be to adjourn at 10 minutes of 11. We have a couple of other things on the agenda, but we have time for them. But if we could hold the detailed conversation
No, I'm totally good.
to a minimum. So, thank you for obviously coming and giving us all this time here.
And your comments on this thing, if you can get them in, that'll be good.
Right. DEP wants comments from the town. I
I
think
thought he said by the end of August.
But we will
End of
I mean,
August-
yeah.
End of August is our drop dead deadline for
Sooner the better.
end of August. But
And do we have your email address?
Yes.
Oh, we do. Wonderful. Thank you.
Yeah, probably wish that
And thank
every
you for
town in
coming.
the state didn't have it.
Okay, any other comments or discussion on this topic? Again, thank you for coming. I know you're,
I have a question, but I don't have to ask it now.
Okay.
Well, I
All right.
he'll be here. Are you gonna stay around until a few more minutes? Just
I can stay a few more minutes, but what I got to tell you is, when's the party?
Party.
This is the only, you guys have done,
Oh, for the-
Falmouth has more than a number that's
Right.
equivalent to half of the total number of sub-abatements in Buzzards Bay. And you've done them all.
Well, all but one, it sounds like.
And we need, put into 208,
That's a
we need
little-
to give an annual update on all of them.
And that'll be up to the state to come up with their share before we do on that one. So, okay.
That's sanity.
Any questions or comments, Paul? You're our ex officio planning board member.
Well, I'm just curious about one thing. It's interesting to see all the flow lines coming from the upper basin to the remains of curving concentrated near 151 and 28. I'm curious if you run the scenario where there will be some treated wastewater discharge in that area, what impact that would have on those flow lines.
We didn't even know anything about that. So yes, we could run that scenario.
It'd be relatively easy to do that.
The scenarios are really easy if they're only, the easiest ones are when somebody says, change this number from 5,000 to 2,000. Then we can do that really quick and turn that around pretty good, and it's really cheap. If somebody says, give me a new, I want to change 15 things, even that's easy, but if you then want to hit a number, then every time you're trying to hit a number, you're doing it by doing a run. You didn't get there, run, and you went over, and then you got to run it. That's 5 or 6 model runs, even though it only sounds like one scenario. So, but the one you talk about, simplest one.
Yeah, we could put our comments and what additional runs we want, but then it's going to become a cost. It's going to be on us and on Bourne. DEP has said, based the way it was structured, no additional model runs. They will not pay for any additional
They
model
won't pay
runs.
for them.
Well, I don't pay for anything else, period. So,
No, I just want to make sure
no, but
that,
I'm just making it clear. So what you want to just contact us the normal way.
Sure.
Right.
We deal with you
Yeah.
guys as the entity in Falmouth, and we'll scope it out.
Great. Thank you again for coming. Update on West Falmouth Harbor Shoreline Septic Remediation Program.
5 minutes or less. We have met with, the Flood State Coalition has been very active. We've been very active. 10 qualified property owners have expressed real interest in the project. We've gone through using a decision support tool with each one of them to identify which of the list of 15 innovative alternative septic systems are most appropriate for their properties. The top 7 that came out of that decision support tool were contacted. All those owners were contacted, given site plans, aerial photographs, as much information as we had on each specific property. They were asked to give us site-specific proposals. Those proposals have come in for all 10 properties, and we have met with half of those properties over the summer, which is fairly challenging to get people's family schedules. But we've met with 5 of them, and there are 3 people who are definitely planning to move forward, and 2 who are very likely to be moving forward. We have the rest of the 5. Corin is on vacation, Corin Peterson from the Board of Selectmen Coalition, and I do these meetings together, and she's away for 2 weeks, so it's come early August when she returns. We will get to the other 5 that are already on the schedule for early August. And we made a presentation to the West Falmouth Village Association and got some additional interest because we want to get 20 and we want to 10. And then the coalition is sending letters to the additional. They had started out with the top 50 based on our ranking criteria of the 50 most significant properties, i.e. in Nashpaquot and Snow Harbor. Now we've expanded that to the rest of the 170 properties that are within 300 feet of the shoreline. That letter went out, I believe it was late last week, and so hopefully, likely we'll get additional interest. There's my update.
That's great. Questions, comments? Good job. Thank you.
You're welcome.
Review and vote on minutes of the prior meeting. Everybody
yeah,
good?
Mr. Chair.
Yes, sir.
One thing, we don't have to debate it now, but think about it. Moving forward to minimize shoring, or even for West Falmouth Harbor, there's a policy issue that needs to be debated or discussed, or even a study possibly initiated, is we don't have any authority to require an individual homeowner to replace or upgrade their septic tank. It's going to be controversial, but any future on minimizing shoring is going to require that authority. So we should get together with the Board of Health or other people and start the discussion.
It may come up in Oyster Pond before it comes up.
I'm assuming that's where it would come up first, but I
Yeah.
mean, it's going to affect all our annual updates.
Good point.
It's something that we've talked about at the Board of Health historically. And it's pretty clear that it's something, that the town, we could declare the whole town a nitrogen impaired area. That's not something 5 Board of Health members are prepared to do. We might be prepared, if we decide that's what we want to do as a town, to take it to town meeting. That's clearly a decision that needs to be made at the level of town meeting.
Right. This committee's been pretty good at finding innovative ways to make things palatable for people, and this will be on our list of things to
Brainstorm.
Brainstorm, exactly. Yeah. Any other comments or questions on the West Falmouth Harbor Shoreline Septic Remediation Project? Review and votes on minutes of prior meeting. All right, they were all sent around. Everybody got a copy of the minutes. Any comments or questions or additions or corrections? If not, a motion to adopt them.
So moved.
Moved.
Second.
Discussion? All in favor?
Aye.
Aye. Opposed? The ayes have it. Steve made the motion. I don't know who seconded it.
Matt.
Matt.
Second.
All right. Report of members and staff.
See, it just asked me to mention that Eric asked me to go to the
Oh, yeah.
Davisville Village Association annual meeting and give them an update on our Bourne Pond inlet widening. And I did that on Saturday. There were about 30, 35 people there. And we had a nice, I gave them a little talk for 5 or 10 minutes and then answered questions. And I think it's pretty clear that they're quite comfortable with the direction we're taking, and just need to be filled in. And we still got a lot of work to do on design and permitting of that, so it's pretty hard to tell them. They were interested in the timeline, and I said, well,
So long week.
a couple of years at best. So
Yeah.
Yeah, we have had contact with DEP to meet with our people to go over the kind of issues that they may have, questions they want answered. It's August, so I don't expect an immediate meeting, but it's on their agenda to meet with us.
Yeah, at the highest level.
Exactly, at the highest level, right. They understand this is a big policy issue. If you can't do it in Bourne's Pond, you can't do it anywhere. It's pretty much the way we look at it. And
Except they are.
except, well, I understand, that's why we're pointing that out.
And that's why we need specifics.
Right, they'll have specific questions, we'll have answers like as we go on. Members and staff report again, on the Wacoit piece, the Charles River, we did send our request off to the collaborative.
Great.
Saying this looks like a great one to fund. I asked them for two things. One was, what have you spent collaborative money on everywhere for the last 5 years? And they did supply me with that. The second question, we haven't got a commitment on, but I think answering the first question will help answer the second one, which was how much money do you have for this next year? And wouldn't this fit well into your priority list? But until we see where they spent the money in the past and how much money they have available now, we can't ask them that question knowledgeably. But it's on their list of things to think about, and it's our list of things to make them think about.
Okay.
So, sure, Ron.
I have a couple things. One is that a couple of months ago now, Amy Costa from the Provincetown Coastal Center the Center for Coastal Studies gave a presentation on contaminants of emerging concern and accumulation in shellfish, or particularly oysters. And you missed that meeting, I think. But anyway, the report with her PowerPoint was distributed, and from that they found basically no impact in regard to hydrophilic compounds. But Amy suggested we may wish to, or it would be a good idea to look at hydrophobic compounds, because it's a different accumulation system in the shellfish. So I'd like to just explore that further and to see what the cost would be and how to move ahead with that, because actually the wastewater superintendent has expressed strong concerns about contaminants of emerging concern and shellfish on a number of occasions. So I think that would be just looking into and see where it stands. I mean, we didn't spend the money on the inlet widening or the dredging of little ponds. So there might be some money there since we didn't use it. So, but for this, so.
Okay, well, the burden would be on the proponents to persuade the committee that public money ought to go into something like this. But,
okay. Well, yeah, public money has went into the other study as well. So that wasn't our money, but it was public money that went into it. But there might be county funding.
I was going to say, where'd the source of that money come from?
With the what do you call it? The Massachusetts Environmental Trust.
Oh, okay.
Trust, right? The license plate money. So into that, yeah.
And they've applied for additional money.
Okay,
the hydrophobic.
for that.
And it's unlikely that the hydrophobic will actually make it into the water. They didn't find, so part of what Amy said
Yeah.
is the hydrophobic compounds don't make it to the water.
Right. They don't get
They
there.
don't
Right.
get there.
So they
the
can
idea of
accumulate.
studying- and the
I
other-
was just, well, anyway, this is expressed by, I'm not, the expertise
I get you.
suggested this piece. And then the other thing is that you may remember that after the vote on the Little Pond system, I had looked at this information thing that had been distributed before the vote, and in it, there was this mention about the $2,500 to $4,000 cost for hookups. And then I remember I did the work and talked to the towns on the vineyard and the suppliers and installers of the grinder pump systems, and turned out that the equipment was like $5,000. So the town has then subsequently taken the action to provide that. Is that money coming from the SRF
No.
grant? No.
No, but it's town authorized bond funds.
Oh, town authorized bond funds, okay. Okay, so on that then, I mean, looking at that and sort of after the fact, but then I looked at this document, the
Little Pond
the
Sewer
Little Pond
Service.
Service Area document that's been distributed to all of the people in the sewer service area. And I have copies for just the pertinent thing, but I don't need to
Well, it's
distribute
going to be
these.
pertinent for the next 60 seconds.
Yeah, it is.
We're adjourned.
It says basically installation and maintenance of all sewer connection infrastructure will be the responsibility of each property owner, that the wastewater superintendent, again, has reiterated a number of meetings, and actually read this passage, or this bullet. On that, though, I then went and checked, because my memory was, I checked my notes on our visit to the vineyard, and it looks like that for the maintenance of the systems on the vineyard, the grinder pump systems, that's being taken over by the town, and the towns there, Oak Bluff, Sedgwicktown, Vineyard Haven. It varies in the state. But the question then is, I wasn't quite sure how this decision was made, that the cost would be. I mean, I don't think we voted on it or anything, but how that was made with regard to the maintenance of the grinder pumps or the connection systems, compared to, say, other towns where the town takes it. And they also go one step further in Oak Bluffs and Tisbury in that they have a generator truck, on a truck, so that during those periods, they go and power those up.
This is probably a good point to have raised a couple of days ago. Some members of this committee are very interested in
Oh, no, I
the committee
don't mean-
hearing about these things 48 hours in advance so they can look
Oh,
at
no,
them
no,
and
no,
have
I don't want,
intelligent
no, I don't want,
conversations.
this is not a point of discussion, this
Well,
is just a
then it is-
report.
Okay.
Yeah, I'm just saying.
The
that
selectmen,
perhaps-
the
perhaps
selectmen and the
We're
town
not-
manager
No, I'm
weighed
just
in
saying.
heavily on how we should manage.
All I'm requesting is that based
This
on
may be a
what my
good point.
findings.
We're not doing it now.
No, I know.
Thank
Based
you.
on the findings.
Okay,
can we
I need a
discuss
motion
this
to adjourn.
At the first meeting in
Mr. Chairman,
September?
just one quick thing. Citizens for the Protection of Wacoit went to the trouble to print these brochures up about what people should do with their dog waste. And we distributed to,
Can you give me one?
we distributed it to both the town of Falmouth and Mashpee, but we have more left for others, veterinarian clinics, anybody who wants to distribute these, so I'll
Great.
pass them down.
Great, thank you. Okay, motion to adjourn by Matt.
So moved.
Second? John, all in favor?
Aye.
Opposed? Guys have it.
I don't have dogs, so.